Hey everyone, this is Marc Bates. I'm a metabolic health coach, and today's topic is the China study. Like I always say, this channel is a community, and I'm here to provide the information that you are looking for and that I can help you with. So, what brought this up was I had actually looked at this over 10 years ago and originally did some written stuff on the China study, and I thought it was dead and buried because it was debunked back then. But somebody brought it up in a chat, and they were saying they're basing their whole premise that humans should not eat meat primarily on the China study. And so I said, okay, fine. If people are still thinking the China study is valid, I need to relook at it and re-up some of my text on it. So this is an updated view of the China study, and I hope you like it. So, what is the most influential nutrition book of the past 2 decades? What if this was built on fundamentally flawed science? Few works have shaped dietary thinking more profoundly than the China study published in 2005. This bestseller convinced millions that animal protein causes cancer and chronic disease, which is something that you're seeing a lot of. Once again, people are once again saying red meat's bad for you. Its impact has been enormous, driving the plant-based movement and changing how an entire generation views protein. But the scientific foundation supporting these claims deserves closer scrutiny. When we examine the actual data behind the China study's bold assertions, a more complex and nuanced picture emerges, one that challenges the simplistic narrative that animal protein is harmful while plant protein is protective. Okay, the correlation confusion. The China study draws primarily from a large epidemiological project conducted across rural China in the 1980s. And what these are basically questionnaires that are given to a bunch of people on asking them what they ate. Right? That's what these type of studies are. This research collected data on hundreds of dietary, lifestyle, and disease variables across 65 countries. The fundamental problem? It relies entirely on correlational data for its human evidence. Correlation, as any scientist knows, does not establish causation. Two factors occurring together doesn't mean one causes the other. This limitation is particularly problematic when dealing with nutrition, where countless variables interact in complex ways. And if you want to understand what correlation, why it doesn't work, let's say you did a study, you found that 60% of the people who go to the beach also ate ice cream from the ice cream vendors. And of these 60% of the people, most of them got sunburn. Well, obviously, eating ice cream causes sunburn. That's correlation. It doesn't work. Okay? When independent researchers reanalyzed the raw data, they found wheat flour intake actually had a stronger correlation with heart disease than animal protein, suggesting entirely different interpretations could be drawn from the same data set. Now here's another thing. Sometimes correlation does help. So let's say if you had 10,000 people and 9,000 of them all had sunburns, and what it was with these 10,000 people is they went to the beach, especially during the peak hours of sun. Well, there's a strong correlation you could make of going to the beach, getting down to your bathing clothes, and staying out there for several hours and getting a sunburn, right? So correlation, while it doesn't prove causation, it can provide good evidence that something's wrong. But it has to be really strong correlation. Okay? In fact, the raw data contains numerous inconsistencies that undermine the book's central claims. Total cancer mortality in some regions was more strongly correlated with plant protein intake than with animal protein, which sometimes showed no significant or even inverse associations. Perhaps most telling is the Tuolumne County paradox. This population consumed more than double the American average of animal protein, yet experienced remarkably low rates of cancer and heart disease, directly contradicting the book's core thesis. This outlier receives minimal attention in the book, despite representing a significant challenge to its narrative. The rat studies and isolated proteins. Beyond correlational human data, the China study cites experiments with rats to support its claims about animal protein and cancer. These studies typically involved feeding rats casein, an isolated milk protein, along with aflatoxin, a powerful liver carcinogen. Okay? Rats on high casein diets developed more liver tumors than those on low casein diets. Well, this led to the sweeping claim that animal protein drives cancer. Okay, but this experimental approach has several critical limitations. First, the studies use purified casein, not whole dairy foods. Real dairy contains a complex matrix of nutrients, including other proteins like whey, which affect metabolism differently. Interestingly, the same research group found that whey protein led to significantly fewer precancerous liver lesions than casein, a finding that receives little attention in the book. Second, not all animal proteins behave like casein. Fish protein has been shown to reduce tumor growth in rodent models. Beef protein tested in colon cancer models showed no increased cancer risk at high intakes. Third, when casein was tested without the powerful chemical carcinogen aflatoxin, tumors did not develop spontaneously. This suggests the protein itself isn't carcinogenic, but may influence how the body responds to powerful cancer-causing chemicals. The leap from isolated casein affects aflatoxin-induced tumors in rats to animal protein causes cancer in humans represents an extraordinary extrapolation unsupported by the evidence. Also, needless to say, while animal studies are important and they help point us in the direction, they are not conclusive on humans. A lot of things will occur in an animal study that will not occur in human studies. Okay? So there are limitations on animal studies. The other thing is whole foods versus isolated nutrients. Right? The China study's focus on isolated casein misses a crucial nutritional principle. Whole foods work synergistically. When we consume dairy, meat, or eggs in the natural form, we get not just protein, but fats, vitamins, minerals, and other bioactive compounds that work together. Take dairy as an example. Conjugated linoleic acid, CLA, found in butter and cheese, has been studied for its potential to inhibit cancer cell growth. Research shows CLA can reduce breast cancer cell proliferation by inducing programmed cell death and inhibiting tumor growth pathways. Biturate, another dairy fat component, shows similar promise. Studies indicate it inhibits colon cancer cell growth by promoting cell differentiation and apoptosis, a programmed cell death. By isolating casein and ignoring these potentially protective components, the China study presents an incomplete picture of how dairy and other animal foods affect health. The mTOR pathway in cancer. A common argument against animal protein centers on its activation of mTOR, a signaling pathway tied to cell growth and potentially cancer. Amino acids like leucine, abundant in animal proteins, can stimulate this pathway. But this argument overlooks a critical detail: the relative strength and duration of different mTOR activators. Research shows leucine only transcendently stimulates mTOR with a modest 1.3-fold increase that fades within 3 hours. So it's modest and goes away real quickly. In contrast, Insulin produces a stronger twofold or two times activation that persists for over 24 hours, right? But they don't talk about insulin. This finding has profound implications. If chronic mTOR activation truly contributes to cancer risk, and we're not saying it does, but that was the China study's implication. Insulin appears to be far more potent and persistent driver than protein. The source of this sustained insulin elevation? Often it's diets high in refined carbohydrates and sugars. The China study largely sidesteps insulin's dominant influence on mTOR, focusing instead on protein. Yet human data from the Nurses' Health Study found diets high in insulinic potential, like refined carbs and sugary drinks, were linked to a 15% higher breast cancer risk. This suggests insulin, not protein, may be more relevant in cancer development. Okay, real quick, it would help the channel a great deal if you could like, subscribe, press the button, and get notified when we release new videos. Thank you so much. I'm grateful if you would do that. Okay, let's look at contradictory human evidence. If we're to use correlational human studies as evidence, as the China study does, we should consider the full body of such research, including studies that contradict its conclusions. Right? The Nuanced study, a 20-year cohort of over 1,100 older Italians, found animal protein intake was associated with lower all-cause mortality, including cardiovascular mortality. This directly contradicts the China study's central claims. A 2018 study in the European Journal of Nutrition found no link between animal protein and cancer, with fish and poultry showing potentially protective effects. Another 2022 study examining 175 distinct populations found higher total meat intake was associated with greater life expectancy. These contradictory findings highlight the danger of building dietary recommendations on selective correlational evidence, especially if you cherry pick the evidence you're going to use. Beyond protein, the insulin connection. While the China study focuses intensely on protein, particularly animal protein, it largely overlooks what may be a more significant metabolic driver of chronic disease, hyperinsulinemia. Chronic elevation of insulin, often driven by diets high in refined carbohydrates, creates a metabolic environment that may promote cancer development through multiple mechanisms. 1. Sustained mTOR activation, as discussed earlier. Increased production of insulin-like growth factor 1, IGF-1, which stimulates cell proliferation. 3. Production of inflammation and oxidative stress. And 4. Altered hormone metabolism, particularly relevant for hormone-sensitive cancers. A diet centered on whole, unprocessed foods, whether animal or plant-based, generally produces lower insulin responses than one rich in refined carbohydrates and sugars. This suggests the processing of foods may be more metabolically relevant than their animal or plant origin. Nutritional complexity and individual variation. Perhaps the most significant limitation of the China study is its reductionist approach to nutrition. It attempts to isolate single dietary factors, animal protein, as the cause of complex diseases with multifactorial origins. This approach fails to account for nutritional context, how the foods are prepared, combined, and consumed as part of the overall dietary patterns. Food quality, the difference between processed and unprocessed versions of both animal and plant foods. Individual variation, genetic, metabolic, and microbiome differences that influence how people respond to different foods. And finally, lifestyle factors, how sleep, stress, physical activity, and environmental exposures interact with diet. These factors create a complex web of interactions that can't be reduced to simple good food, bad food categorizations. Remember, we always stress here a very holistic approach to how to get metabolically healthy. A more nuanced approach to nutrition. The enduring popularity of the China study speaks to our desire for simple, clear dietary guidance. We want straightforward answers to complex questions about what to eat. But nutrition science rarely provides such clarity. The evidence suggests a more nuanced approach. Focus on whole foods, whether from animal or protein sources. Minimally processed foods generally support health better than their refined counterparts. Consider metabolic context. How foods affect insulin and other metabolic pathways may be more important than their origin. Recognize individual variation. The optimal diet varies based on genetics, activity levels, health status, and personal goals. Evaluate evidence critically. Be wary of nutritional claims based solely on correlational studies or limited animal research. And finally, consider nutrient density. Both animal and plant foods can provide valuable nutrients when chosen wisely. Choose the ones that provide the most nutrients and the most varied amount of nutrients per 100 grams, let's say, of that food source. That's very important when considering what to eat and how to base your diet. Okay? Beyond the plant versus animal debate. Okay? The legacy of the China study has been a polarization of dietary discourse into plant-based versus animal-based camps. This division has generated more heat than light, obscuring the nuanced reality of nutritional science. The evidence suggests we should move beyond this false dichotomy. Quality matters more than category. Processing matters more than provenance. A diet rich in whole, unprocessed foods, whether they include animal products or not, generally supports health better than one dominated by refined and ultra-processed options. The China study deserves credit for encouraging greater consumption of plant foods, which provide valuable nutrition and phytochemicals. But its vilification of all animal proteins based on limited evidence has led many to avoid nutritious foods that could support their health. As we continue to advance our understanding of nutrition, metabolism, and disease, we would do well to approach dietary evidence with appropriate skepticism and nuance. The story of protein, cancer, and health is far more complex than a single study or book can capture. The most reliable guide remains the totality of evidence viewed through the lens of metabolic mechanisms and individual context. I'd also like to make sure that we understand that I'm a big proponent of the carnivore lifestyle for people who are coming off of eating a heavy carbohydrate-based diet with potentially a great deal of ultra-processed food and trying to heal. The carnivore diet, which may be a little strict for some, is by far the most healing diet you can find evidence for. Okay? Doesn't mean you have to stay on it for life, though many people will choose to do so. Because if you spent 20, 30, 40 years eating a high carbohydrate diet, it may take quite a while to heal your body completely from that. Okay? Doesn't mean that you can't add whole foods like vegetables and fruits later. But initially, the best way to heal is to minimize all the confounding factors and get down to the most effective diet that provides all the nutrients your body needs with the least inflammation and the least insulin if you came off of a very high caloric, high carbohydrate type diet. Okay? Just keep that in mind. I'm not against eating vegetables. And even as a carnivore, some small amount of vegetables is part of that process, right? But keep in mind, we're trying to heal. As a metabolic health coach, I'm trying to help you heal. Okay. Want to thank you for watching. Once again, please, if you have comments or questions, leave them on the channel. If you have an idea for something you'd like me to look into for you and produce as a video, let me know as well. This is a community. We're here to help each other. Thank you very much.